In the previous examples, we talked about an object moving in a horizontal circle. If it's moving in a vertical circle, you have to think about the weight of the object as well. And remember that the thing that's moving in a circle, that the sum of the forces on that object should add up to mv squared over r. If you swing a ball on a string in a vertical circle, then to keep the centripetal force constant, the normal force has to change throughout the motion. And you've noticed this if you try to swing something in a circle, right? You have to change how you move your hand. You have to adjust your wrist as you're swinging it in a circle. And so you can feel the change in this force required to keep it moving at that same speed. At the top of the circle, the weight is going to point toward the center of the circle. And at the bottom, the weight's going to point outward from the circle. And so you get a situation that looks like this. At the top of the vertical circle, so a Ferris wheel for example, the radial acceleration always points towards the center of the circle. His velocity will be this way, but his weight is also pointing downwards toward the center of the circle. And so the radial acceleration and the weight are in the same direction. At the bottom of the circle, the radial acceleration still points towards the center, but his weight points downwards. And now they're in opposite directions. So in the next example, we're going to determine the normal force on a person riding a Ferris wheel like this at the top and bottom of the Ferris wheel.